because of this, we're going to use this procedure.
We will try both.
But you will try both and report the one that works best.
Yes.
You're getting the game. Yves Rossel tells us the growth function is almost identical to the SEM function, but a mean structure is automatically assumed and the observed intercepts are equal to 0, while the latent variable intercepts are freely estimated. So in latent growth curve modeling, Rossel uses the growth model command, which makes sense because it's a repeated measures anyway. Okay? The model is equal to I for the intercept is equal to 1 times 1 times 1 time. And this is just one factor. This is just the enjoyment item. So it repeats 9 times. So it's 1 times everything because it's constant. Because there's only one beginning point. There's not multiple beginnings. There's only one beginning. The beginning is 1. And then, of course, there can be no change at the beginning, but there's a constant, because the data is collected basically the first time, the second time, the third time, or 2 days, 4 days. You could change this to 2, 4, 6, 2, 4, 6, and then you go, that's Friday, and then get to Monday, 6, 7, 8, oh, and then 9, 11. You could just count it, set it as the number of days. Okay? It's a what you need is a constant to be able to say this is the constant that represents the time scale. Yes?
I have a conceptual question. Can we return to the model picture? Does it mean that we measure the same mean, the same starting point for each person according to several different subscales? Positive emotions, this mean, and negative emotions, the same mean, and...
I wouldn't... If there's a way to do multiple things simultaneously, I don't know about doing that. We always, because we were restricted to 166, what it's doing is we're only studying one emotion. So it's just a study of how does this emotion change?
Oh, so it's just one emotion.
Yeah.
And we have several separate models for each kind of emotion.
Yes.
And when we interpret this, we say that, hey guys, to your midterm test result, several things are related. The first one is your previous test GPA,
Yeah.
but also how you felt initially on this emotion and how changeable you are in this emotion during time, how stable or unstable you are. And these 3 factors
Might
influence your
test score.
And we have separate models, the same models for the different emotions.
Yeah.
Thank you.
Good, you understand perfectly what I said. But you didn't believe it, so you had to ask. So, then we want the fit of this model. Growth. There's the model. There's the data set. Missing. If there's any missing, maybe you want a maximum likelihood estimate them, but I'm not sure there's any missing. You need to check that. Then you want the summary fit. The fit, the measures, the R-squared, the standardized. And then you want to see the picture. What does it look like? So, 233 observations, 40 degrees of freedom, and 77 and 79. Ooh, maybe that's because it's estimating so much data. So you'd want to go back and maybe clean out people with missing data, because there's 9 time points. So we had a rule where we said, if you gave us 7 out of 9, we'll keep you and estimate you're missing. But if you have less than 7, we threw you out because we weren't sure what your answers were, because these are highly individual. We don't want to maximize the parameter, we want to maximize the truth of you. And psychological truth is more important than statistical modeling. So you might want to look at the data and say, that's a crappy model, maybe it's caused by the too much missings. But if it's not a lot of missing, maybe the model is okay. Then it's just a bad model. Maybe it's because, as you saw on the averages, things were not constant. So maybe that's the problem, and maybe it's only constant, each week. Okay, so there's two plausible hypotheses about why the 9-time point model doesn't really fit very well. Okay? Too much missing? Check it. Maybe it's not a 9-time point linear model. Maybe it's only a 3-time point, 3-time point, 3-time point. The variables for the intercept are all set at 1 because they're constant. The variables, the loadings for S are set at 0, 1, 2, 3, 4, 5, 6, 7, 8. That's the set value. And here's the standardized all value. 58, 60, 60, 60, 50, 50, 60, 60, 60. Pretty constant around 0.60. Not a lot of change. 07, 22, 27, 34, 55, and by the time we get to the end, 60 and 60, they're about equal. The covariance between intercept and slope is 0.02 negative. But it's not statistically significant. So they're independent. There's no systematic relationship between where you started and how changeable you were over time. Maybe that would be constrained if we controlled it for GPA, right? And the intercepts are all set to 0, thank you very much. And the intercepts are not negative, yay. The variances are all something, and they're all positive. And the R-squareds are 34, 35, 38, 36, 30, 33, 42. Notice the pattern. How much are we explaining? It's around slightly increased in the first week. It goes down and up in the second week, and it goes down the lowest at the day of the test. So maybe these people are sane. And then when they get the results, it's much more explaining that emotion in that third week. So it does, just on this one item, kind of really look like when I know my results, I can explain my emotions much more. Slight increase, wobble. So maybe it really isn't a linear relationship. That's the point. And this is what it looks like. Standardized, wait a minute. Oh, standardized at the level -27. So that was actually statistically not significant, but it reports as -27. So there is a slight tendency, if you had high, you didn't change. If you started low, you tended to change. So it's almost, I think, in talking about this as we were developing the analyses with my co-author, Liz Peterson, she's suggesting that high-scoring individuals just tend to be more emotionally stable and self-regulating than low-scoring people. And you can see the regression weights standardized here, and you can't read them unless you spin it sideways somehow. If you did it with a latent variable, and this is how Bauer and Patrick Curran, they have a free course on latent curve on factor analysis that they've uploaded and made freely available. And so I want to acknowledge that I got some of my code from their examples. This is this is the code for the positive emotion. So there's enjoy, hope, proud, relief. Time 1, time 2, time 3, 4. Right? So very straightforward. And then I is equal to 1 times the positive. So now I'm regressing the latent curve predictors of intercept and slope on the factor, not the individual item. So now I'm relating it to pause. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right? So I'm not trying to do positive and negative simultaneously. Believe me, I tried and the damn thing didn't work. So maybe it just goes to show you just, can't do everything you want. So then there's the same model. There's the fit command. There's the summary command. And there's the model output. And it's 0.29 instead of 27. So that relationship of the tendency to start and change is, and you see all the items in here, and obviously you have to look at the summary information to see, is this an acceptable model? Can you believe this model? And are there problems with it, and how might you fix it, and so on. So we have the rest of today to play with invariance testing and latent curve modeling. Do you have any questions? Because it's only 12:30, and what time is lunch?
13:15. 1:15.
Okay, so we have 45 minutes. Wow, I went fast. Because I didn't... Yeah, anyway. Do you have any questions or comments before you start playing? Because you have the rest of today to play and test with your own data or test with my dummy data.
Yes, about those colorful models you showed before very quickly when you said about interaction effect.
Do you want to see the result? I can show you the result from the paper. And there we go, there we go, there we go, there we go, there we go. 15, Peterson. This is in Contemporary Ed Psych. And where are we here? Come on, where'd I go? Results. Effective AEs on test scores. Okay, keep going. Keep going. It's not that one, it's these. Table 7 and 8. Can I get closer to the top of the screen by doing this? Close that and make it bigger. Alright. So this table 7 shows the relationship of the latent curve model according to whether it's study week, test week, or feedback week as a predictor of the test score. So here's your emotions, the positive ones and the negative ones. And what we found is, notice none of these, except here, are statistically significant. And none of these are statistically significant until we come here. And what it says is, in the feedback week, your starting feeling is a predictor of your test score. 0.26 and 34. If you have high positive emotions at the start of feedback week, probably because you got a good score or a score better than you expected, or at least as good as you expected, that is positively regressed onto your test score. Then the negative emotions are negatively.
Feedback week is after your test.
So this is the study week before the test. This is the week of the test.
Yeah.
Now I have my scores.
Yeah, and we are talking about prediction. Prediction is when we predict something is ahead of this. And here I can...
We did not ask them to predict their test score. What we're saying is that there's a positive, in our argument, causal relationship between your emotion and your test score. That if you started with a high positive and low negative, you did better on the test. But we don't see this until they know their results.
Right, so this model does nothing to actually predict. Not in the sense of regression, but in the sense of real-world variables.
Correct. Because what are you going to predict? From their emotions with the future score? This suggests that there is a possibility that students with high positive emotions and low negative emotions tend to get better marks. But you don't see this relationship until they have their feedback. Because uncertainty gets in the way of the relationship. So now I know, and it turns out the high scoring students had better positive and lower negative. And it's only in the start value at the beginning of the week, not the changeability. Changeability is not related. So, what are you trying to, when you talk about prediction, what are you trying to predict? Who's going to get a higher score? Well, who's going to get a higher score will be people with high positive and low negative values, but you couldn't see that until they knew their score.
Yeah,
Yeah.
we understand, I think.
So, in a sense, emotions do not predict test scores. Emotions,
Follow test scores. Yeah.
achievement leads to appropriate emotion. Lack of achievement. So, another way to look at this is, what was the GPA relationship? I wish I could get it to the top of the screen, but I can't figure out how to do it. So, this is GPA predicting emotion. No effect until we get to here. No effect until we get to here. And it's the same relationship. And GPA positively predicts positive emotions and negatively predicts, or regresses onto
Good
if you
students
prefer.
receive better grades and bad students.
So,
receive
if you're
good.
smart, you're positive and not negative, and you do better. If you're not so good academically, I use the word smart to mean academically competent, then your emotions are not a valid indicator of your competence and capability. So if I was going to make a clinical recommendation, I'd be saying, the student comes and he comes to you and he goes, oh, I'm really worried and I'm anxious and I'm depressed. Can you get me out of the exam? No. Go and study some more. Right? Go and learn something. Get a tutor. Actually become competent. And then your emotions will be legitimately controlled because you actually can do this stuff. If you're all freaked out with high negative emotions and low positive emotions, it's usually because you're not very good. And maybe you haven't actually been disciplined enough to put the effort in. Just because you've always been good doesn't mean you're going to keep being good. You might have been the best in your high school, but now once you go to university and you're surrounded by kids who were best in their high schools all over the country, and you discover, shit, I'm not so good. You either give up or you start working harder. Start working harder, dumbass. Now, if they've been working as hard as they can, maybe they're doing the wrong things. Like trying to memorize everything instead of trying to understand things. Maybe they can be taught to study better. And if they're still studying well, putting in lots of effort, and not getting it, maybe you should change career. maybe this is not the place for you. I mean, we can't change university education to cater for barely competent people, can we? Should we? Do you want to do that? I'm an elitist, I'm a technocrat, I believe in merit. If you can't do it, then bye-bye.
When you asked them about the emotions, how were the questions formulated? Were they just, I felt happy, like on the slides?
Yes.
Because
And it was a digital survey. They were not interviewed, it was a digital survey. Click, 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 click.
Yeah,
9 times over
I mean, there are so many factors why you can be happy or unhappy.
Exactly.
Apart from.
But that's why we tracked it, and we had it tracked against 2 events. The midterm test and the feedback day. So we can anchor, so you could think of it as an interrupted time series, is that, you know, we knew what was happening, at least in this course. We don't know what was happening. Their cat could have died. I don't know. You know? But that's just the random that affects everybody simultaneously. Georg.
Yeah, so the cat dying thing, that was what I was going to ask. So, I mean, obviously that's a jokey kind of proposal, but it really can happen that
Yes?
external factors affect their emotions.
Absolutely.
So I'm trying to understand how are you correcting for this over the time periods, and if it's already built into the model, and if so, how?
It's called the residual or the variance.
So it just all goes into the residual?
It goes all into the residual because we didn't have a sophisticated model of, you know, by the way, did anything bad happen to you today? Yes, no.
So your diagnostic for this is you just monitor the residual and you make assumptions based on those results?
Well, we have to assume that everything we didn't measure is just random and we can't account for it. And if we have large enough data, it kind of gets washed out.
And if I understand correctly, your residual shows that you predicted the least amount of variance while they were taking the test?
Well, that analysis, yes, exactly. But, yeah. And yes, in a perfect world, you would collect other constructs and other measures, but this survey was not 9 items, but it was like 20, 30 items, and they had to do it 9 times, and they had to do it within 24 hours of the class. So, or 24 hours, they had to do it within 24 hours of the message, the prompt being sent to them for it to count. And only, it was a class exercise, so there were about 390 students in the class. Most of them did it, but only 166 did 7 and gave us permission for research purposes.
How many?
Out of 390. So we only ended up with 166, and some, as I said, the first review editor went reject without review because that's too much lost data. And you go, well, wait a minute, repeated measures. If you get 380 and then 360 and then 350 over 9 time points, the odds on losing what, 10% every time? So 10% is 30, 30, 30. You start to get down to that. Plus they had to give us permission to use it for research, not just you had to do it for the class, but you gave us permission or not to use it for research. The co-author, the third author in this was a master's student, and she did this for her master's degree in psych. So, and she has not gone on to academia. She's married with a kid and doing youth clinical work in her church. A loss to academia, but we at least got a publication in a good journal out of it.
And to compare the difference between intercept and slope, what did you use in like t-test?
No, because the model shows you the value and the standard error, and it calculates whether that observed value is statistically significant or not. It's built in. When you have a regression weight, it tells you whether it's statistically significant. Because that's a regression weight, remember? From the model. So what it says to us is feedback really is influential on stabilizing people's emotions. Because that's when they know. Up until that time, they don't know. So even good students are freaked out. Even bad students are happy and relaxed. Bad students don't know they don't know. Right? You know that effect? It's the Dunning-Kruger effect. So they don't know that they don't know, and then when they get the result, they're suddenly, oh. And good students get angry because I got number 13 wrong, and I thought I knew that one, you know, like, and that's, but knowing makes a difference. All right. So that's the result of that. And if you really wanted to read that, you could. It's this article here.
Could you also show the reference for your article, if it was published, on this differences between different groups of students, minority, Asian, Pacific?
Oh, the structural model with that invariance? Yes, it was published. And it's in the journal, European Journal of Psychological Assessment. You need a DOI number? So, yeah, so, oh, okay. That's one way to do it. Take a picture. Yeah, the journal, it's actually considered a good journal. So 2009 was a good year for me because I got published in this journal and in Learning Instruction, so I thought that was a pretty good year. But I have to say, this journal had a page limit of 20 pages for submissions, and ours was 21. And they sent it back to us because it's too long. And I looked at the paper and I went, wait a minute, check the paper size. It was on 8.5 by 11, American paper size. So I changed the paper size to A4, European size. Suddenly it was 20 pages. We sent it back to them. And by the time we did the revisions, it was more like 22 pages. First rule of submission for grants or for publications, follow the instructions. But it's sometimes as simple as that. Okay? Right. Are we stalling to avoid having to start doing some practice until after lunch? All right, any other questions? Because this is all useful. And the article on invariance testing, because we're doing this, is in Teachers. Invariance testing was 2017. Come on, Gavin, can't you see it? Invariance testing, yes. Come on. Teacher. No. Look at the methods. There it is. No, that's the article. That's not it. It's, come on. Gavin, you're almost there. There it is. This is the article that is on invariance testing for multi-group confirmatory factors analysis. That's the one with the Louisiana, New Zealand comparison data, and we explain how we understand invariance testing in that. That should be available for anywhere. And if you can't find it, you just write to me and or find my ResearchGate page and ask for a copy of it, and I just go click, 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 and it goes to you, and I don't have to find it in my system and mail it to you. You do the finding on my ResearchGate, and then I go, yes, of course you can have it. You can't put articles like this, the published version, out in the public without getting in trouble from your employer and the publisher.